Hi everyone, my name is TTJ Richard and welcome to my channel. Today our discussion on numerical and computational methods will be finding at least one root for complex polynomial functions. So we said that to find a root for complex polynomial functions, we have a lot of methods we can use. And was the bisection method. Last, I have a video where we use the bisection method to find at least one root for complex polynomial functions. If you have not watched that video, please check it out on YouTube. Today, before the video ends, we'll look at another method, which is the method of successive approximation or fixed position method, which is also known as the iteration method. So before the video ends, I will take you through the procedure that involves the method of successive approximation. Then we'll take some sample problems and we'll find at least one root for such polynomial functions using the iteration method or the method of successive approximations. This will be a very interesting engagement, so please be my guest. So with the method of successive approximation, if they give us a polynomial function f of x, to find at least one root for it, we equate that polynomial function to 0. After that, we make x the subject of itself. So after we do that, we get x equal to x naught. And what is this x naught? The x naught is the interval halving of the root that exists between that interval. Or in other words, the halving of the interval that contains at least one root of this polynomial function. And we can get that interval using the location theory. Very, very important. So if we get location, we use location theory, we realize that f of a is equal to maybe negative b or negative c, and f of b is equal to d. That means at least a root exists within the interval ab from the location theory. Now our x naught will be the interval a plus b divided by 2. After we get the x naught, we substitute it in a place of x in the equation that we make the subject. So we will get our x1 to be the first approximation as in place of x we substitute x naught, so we'll get x naught. Now our x2 will be substituting x1 in place of x. So our x2 will be the substitution of x1 in place of x. Our x3 will be the substitution of x2 in place of x. And our x4 will be the substitution of x3 in place of x. So we continue that until we reach Sn equal to the substitution of Xn minus 1. So this is generally the procedure that involved in the method of successive approximation. So now we take some sample problems and we see how we can find at least one root for such complex polynomial functions using the method of successive approximation. So now let's look at our first question. They say find at least one root for the function sp plus s squared minus 1 equal to 0 using the method of successive approximation correct to 4 decimal places. So how do we do that? Remember, our f of x is equal to s cubed plus s squared minus 1. So what do? We equate this to 0. So s cubed plus s squared minus 1 equal to 0. Now we try to make x the subject of itself. So we have s cubed plus s squared equal to 1. What is common here? S squared is common. We'll be left with x plus 1 equal to 1. We can divide both sides by s plus 1. So our s squared will be equal to 1 over x plus 1. Then making x the subject, x will be equal to the square root of 1 over x plus 1. So we have succeeded in making x the subject of itself, where both sides of the equation does not contain any power more than 1 of x. Very, very important. So after we make x the subject of itself, we find x naught. So, since x is equal to that, we have made it the subject of itself. We find the interval that at least one root exists or occurs. So we find f of 0 using the location theorem. F of 0 will be -1. And our f of 1 will be 1. This implies that at least a root exists within the interval, within the interval 0, 1, closed. So we find our x naught. Our x naught will be equal to 0 plus 1 divided by 2. That's finding the average of the interval or halving the interval. This will be equal to 0. That will be 0.5. That will be 1 over 2, which is 0.5. So now after we got x naught to be 0.5, we substitute it. So we find x1. We say our x1 will be equal to the substitution of our x naught in the place of x. So we substitute the x naught in place of x in the function. That will become our x1. So our x1 will be equal to the square root of 1 over 0.5 plus 1. And when we do that, we'll get the square root of 1 over 1.5. And that will be equal to 0.8165. So that will become our x1. Our x2, which is the second approximation, will be the substitution of x1 in place of x in the function. So our x2 there will be equal to the square root of 1 over 0.8165 plus 1. So this will be equal to the square root of 1 over 1.8165. And when we solve that value, we get 0.7420. Now our x3 will be the substitution of x2 in place of x in this equation. That's in this function. So our x3 will be equal to the square root of 1 over 0.7420 plus 1, which will be equal to the square root of 1 over 1.7420. When we solve that very well, we'll get 0.7577. That becomes our x3. So what will be our x4? Our x4 will be equal to the substitution of x3 in place of x. So our x4 therefore will be equal to the square root of 1 over 0.7577 plus 1. So when we do that very well, we solve that very well, we'll get the square root of 1 over 1.7577, and that will give us 0.7543. So we can find our x5. Let's leave it to the last approximation should be x5. Will be equal to the substitution of x4 in place of x. So our x5 will be equal to the square root of 1 over, remember x4 is 0.7543, so 0.7543 plus 1. This will be equal to the square root of 1 over 1.7543, and that will give us 0.7550. So we can conclude that at least one root of the function x cubed plus x squared minus 1 is 0.7550. I hope you get that. We'll solve another question so that you'll be abreast with the concept. So let's look at our second question. It says use the method of fixed position to find one real root of the function 2x equal to cos x plus 3 correct to 4 decimal places. So how do we do that? First, we have to make x a subject of itself. Remember that. So we can say x, we divide both sides by 2, we get x to be cos x plus 3 all over 2. So after we do that, we find our x naught. And remember, we can get the x naught from the location theorem. So a function f of x can be equal to 2x minus cos x minus 3 from this. So if we find f of 1 will give us negative 1.999. And f of 2 will give us 6.164. Since f of 1 is negative and f of 2 is positive, we can say that at least a root exists within the interval 1, 2. So our x naught will be equal to 1 plus 2 divided by 2. 1 plus 2, that's 3 divided by 2 will give us 1.5. So now we find our x1 by substituting x naught in place of x in this equation. So our first approximation, which is x1, will be the substitution of x naught in place of x in this function. So our x1 will be equal to cos into bracket 1.5 plus 3 divided by 2. When we do that very well, we'll get 1.99983. It will be our first approximation. Now our x2 will be the substitution of x1 in place of x in the function we made the subject. So our x2 will be equal to cos bracket 1.99983 plus 3 all over 2. When we do that very well, we get our x2 to be 1.99970. So we find our x3. Our x3 will be the substitution of x2 in place of the x. So our x3 will be equal to cos 1.99970 plus 3 all over 2. When we do that, we'll get the same 1.99970. This implies that when we continue to find x3, x4 will get the same value. Then we can conclude that at least one root of the function, as the function given to us, which is 2x equal to cos x plus 3 is 1.99970. So since they say correct to 4 decimal place, then we can say it's 1.9997. I hope you get that. So at least one root for the polynomial function given to us is 1.9997. We'll take another problem and see how we'll deal with it. So let's look at our third question. They say use the iteration method to show that the solution to the equation 2x minus log s equal to 7 is s equal to 3.789. So how do we do that? Remember, they say iteration. So we know that our function is 2x minus log s equal to 7. What do? We make s the subject of itself. Remember that. So our 2s will be 7 plus log s. On divide both sides by 2. S will be equal to 7 plus log s all over 2. What next? We find x naught. X naught will be gotten from the interval having using the location theory. So remember, our f of x can be written as, from this function, as 2x minus log s minus 7. So when we find f of 3, our f of 3 will give us negative 1.477. That's substituting 3 in place of x here. And f of 4 will give us 0.3979. So since f of 3 is negative and f of 4 is positive, it implies that at least a root exists within the interval 3, 4. Then we can find our x naught. Our x naught will be equal to the 3 plus 4 divided by 2. 3 plus 4 is 7, divided by 2 will give us 3.5. So now we got our x naught. We substitute in place of x here to get our x1. So we say our x1 will be the substitution of x naught in place of x. So our x1 will be equal to 7 plus log 3.5 all over 2. When we solve that very well, we'll get our x1 to be 3.7720. Now find our x2. Our x2 will be the substitution of x1 in place of x. So our x2 will be equal to 7 plus log 3.7720 all over 2. When we do that very well, we'll get 3.7883. So since we know our x2, we can find x3. So x3 will be the substitution of the x2 in place of x in the equation. So our x3 will equal to 7 plus log 3.7882 all over 2. And we'll do that very well. We'll get our x3 to be 3.7892. So when we correct this to 3 decimal place, we get a 3.789 as they say we should prove. Therefore, s equal to 3.7892 is a solution to the function 2x minus log s equal to 7 as required. I hope you get that. So we'll solve one more question on this, then we'll see how we'll go about it. So we'll solve our last question on the method of successive approximation or the fixed position method. But before we do that, please remember to like my video, share and comment. Your comment keeps me going. Also subscribe to my YouTube channel if you are yet to. So you can now pause the video and try solving the next question, which says that use the method of fixed position to find a real root of the equation x cubed minus 2x minus 5 equal to 0. So how do we do that? Remember, first we make s the subject of itself, and both sides of the equation must not contain a power that is more than 1. So if we let find x cubed minus 2x equal to 5, when we bring the x out here, we'll have, so when we try to bring the x out, we'll get x squared minus 2. And these contain a power more than 1. So what we need to do is to rather send this there. So when we send it there, we get x cubed equal to 5 plus 2x. So we can make x a subject now. X will be equal to 5 plus 2x, all exponent 1/3, or the cubic root of 5 plus 2x, or the cubic root of 5 plus 2x. Now we need x naught to start the approximation. How do we get the x naught? We find it to get the x naught. We find the interval within which at least a root exists using the location theorem. Remember, our f of x is equal to the x cubed minus 2x minus 5. So our f2, if we find f2, we'll get -1. And our f3 will get 6. So since this is negative and this is positive, that means at least a root exists within the interval 2, 3, and close. So you can find our x naught. Our x naught will be 2 plus 3 divided by 2. 2 plus 3 is 5 divided by 2 will be 2.5. So our x1 will be the substitution of x naught in place of the x. So x1 will be equal to 5 plus 2 times 2.5 exponent 1/3. When we do that very well, we'll get 2.1544. Now we find x2. x2 will be the substitution of x1 in place of x. So our x2 will be equal to 5 plus 2 times 2.1544 exponent 1 cubed. Exponent 1/3. When we do that very well, we solve it very well, we'll get 2.1036. So we find our x3. Our x3 will be equal to 5 plus 2 times 2.1036 exponent 1/3. Thus, our x3 will be the substitution of x2 in place of x. So when we do that very well, we'll get our x3 to be 2.0959. We find x4. x4 will be the substitution of x3 in place of x. Our x4 will be equal to 5 plus 2 times 2.0959 exponent 1 cubed. Exponent 1/3. So that will give us 2.0948. We find x5. x5 will be equal to the substitution of x4 in place of x. This is an interesting one. x5 will be equal to 5 plus 2 times 2.0948 exponent 1/3. When we do that very well, we'll get our x5 to be 2.0946. So we can say at least one root of the function x cubed minus 2x minus 5 equal to 0 is 2.0946, correct to 4 decimal places. I hope you get that. So we'll end it here today. Please remember to subscribe to my YouTube channel before you sign up. Until we meet again on another method to find at least a root for complex polynomial functions. My name is Kepsi.